Welcome to Study Loop.
We're told the angular momentum quantum number L is equal to 2. So in units of h bar, we are going to find the maximum possible value of L sub z. Well, L, the orbital angular momentum, is given by the equation L is equal to the square root of little l times L plus 1 multiplied by h bar, where L is an integer value from 0 up to n minus 1. L sub z is equal to m sub L, which is equal to an integer value of 0 plus or minus 1 all the way to plus or minus L times h bar. So what we have here is if we plug in L is equal to 2 into our equation, that means that L, the maximum value of m sub L, is equal to 2. You can say at max, at most, or at max. Okay, so then if that's true, LC to be equal to 2 times h bar. And that's the question, or the answer for question A. Okay, B. To find the value of L, and it asks which is larger, L or the maximum possible value of L sub z. So let's find L. Well, according to our equations, L is, or capital L, momentum, is equal to the square root of L, which we're told is 2, times L plus 1, which is 2 plus 1, so times 3, multiplied by h bar. In other words, it's equal to the square root of 6 times h bar. And then for C, we are asked to find the different angles for the vector L made with the z-axis. And how does the minimum angle for L equal 2 compare to the L equals 3 calculated in the other question? So scroll down for C. We have L equals 2, the possible values for L sub b. We have L sub b equal to 0, because m sub L can be equal to 0 all the way up to plus or minus L. So 0, plus or minus 1, and plus or minus 2 are the allowed values. So how about when it equals to 0? Well, it's equal to 0. How about when it's equal to plus or minus 1? L sub z is equal to plus or minus a bar. And it's equal to 2. Sub z is equal to plus or minus 2h bar. Okay, so based on this, we can find the angle between L and the z-axis using the fact that the angle, which we can call theta, is equal to the inverse cosine of L that we found in, or L sub z over L. Okay. So for the different values of L sub z, we can have different angles. So we can call theta 0 for when L sub z is equal to 0. And so this gives a value equal to, so what's cosine of 0? Cosine of 0 is equal to 2. Or excuse me, inverse cosine of pi over 2 is equal to 0. So inverse cosine of 0 is equal to pi over 2. How about when theta is coming from L sub z equal to plus or minus 1? To do plus minus 1, we simply can 1 or -1, in for L sub z, so we had plus or minus h bar there. So when it's positive, you get 65.9 degrees. And when negative, you get 104 degrees. Okay, and then how about when it's equal to plus or minus 2? Sub z is equal to plus or minus, we'll call this plus or minus 2. So when it's positive, you get 35.3. And when it's negative, you get 140.7 degrees. So we observe that the minimum value is 35.3 degrees. Not 3.5. Okay. So it also doesn't just ask us to find the minimum. It says, how does this minimum angle compare to the minimum angle for L equals 3 calculated in example 41.3? So it's larger than the minimum angle for L equals 3. So we can say that means that as L increases, the minimum angle value decreases. Our solution to the question.